In this video, we'll look at rotations on the coordinate plane, and we'll be using transparencies to help us rotate a figure. So based on our observations, we had our directions of the rotation: clockwise 90 degrees quarter turn, 182 quarter turns, and we made our observations by creating an object and see how the object moves if we need to move it clockwise or counterclockwise around the given center of rotation. So the object can move either clockwise or counterclockwise. We need to know what point is the center of rotation and how many degrees to rotate it. So the rotation is a transformation that turns a figure about a fixed point. So we need to know that fixed point where to rotate the figure around or about, for what angle and what direction. So every time you have to rotate the shape, there are three pieces of information you need to know about the rotation: the point of rotation, or the center of rotation, that's the point where the motion begins, given angle, how far, given angle means how many degrees to rotate, and then what direction. In other words, which way to rotate. If I have an image here and I have two triangles, this rotation is 90 degrees clockwise. The pre-image ACB or ABC is the object, or the pre-image where the original shape is. The image labeled with primes, A prime, C prime, B prime, is the after rotation. So if I was to check this rotation is around the center of rotation, origin, or 0, 0. The original shape, ABC, has been rotated clockwise, so we have the motion with the clock 90 degrees. So when we look at the rotation, we need to look at our quarter turns. So the original shape, going back, had this starting point. The ending point is after you have 1/4 turn. In other words, this arrow has to be lined up with this axis. So once you have your center of rotation, we're matching up to the grid. If I match that to the grid and line it up, it overlaps exactly. So therefore, this explanation was the rotation of 90 degrees clockwise. So this triangle was rotated clockwise 90 degrees to result the A, B prime, and C prime triangle. If you connect the vertices, let's say B with B prime, or A with A prime, or C with C prime, every single vertex of the pre-image and image will be at 90 degrees. So that's when we can check with our protractor. So we have, let's say, the angle between A and A prime. That's a 90 degree angle. So if we focus on A, or B and B prime, or if I make the connection a similar way from C to C prime, and measure the angle, that is 90 degrees as well. So every vertex moved and rotated to a 90 degree angle. So the rotation or the quarter turn was clockwise 90 degrees. Let's see a few examples here of rotations that I have on the coordinate plane. Two triangles. Which is pre-image, which is image. So let's say on this example with the top triangle, I can rotate it 90 degrees clockwise, and that will be its image. Or for the same image, let's say ABC, I can rotate it 270 degrees anti-clockwise or counterclockwise, 1 quarter turn, 2 quarter turns, 3 quarter turns, and I'll end up in the same place. So if I was to put in the directions, explain what transformation was done from the pre-image ABC to the image A prime, B prime, C prime, two different explanations could work. You can say that this was a rotation 90 degrees clockwise around the origin, or this was a rotation 270 degrees counterclockwise around the origin. So thinking about what explanations could work, two different ones could end up in the same image. So if that was a test, I would take either one. What if I have to rotate a rectangle? Let's say here we have A, B, C, D, 90 degrees clockwise, about center of rotation 4, 4. So that was my pre-image right here. And the center of rotation doesn't have to be always the origin. The center of rotation can be any point on the coordinate plane. So given the point 4, 4, that is the center of rotation, which corresponds to the vertex A. So the center of rotation is what I need to be marking on my transparency. I have my vertices, and if this is my center of rotation, 0.44, this is where I need to mark my arrow, where my starting point is right there on the axis where 4, 4 is the intersection, and then 90 degrees clockwise is the image A prime, B prime, C prime, D prime, which is labeled in our figure. So the actual shape can be rotated around any point on the coordinate plane. The direction is given by the problem, clockwise. How many degrees? 90. 1 quarter turn. Those were shown examples. Now let's see how to actually rotate a figure on the coordinate plane. So first example, I have to rotate triangle ABC clockwise 180 degrees about the origin. So my three key components are, I need to know what is my center of rotation, that's the origin, how far, 180 degrees, what direction, clockwise. So thinking about the three components, I'm going to mark my center of rotation, which is the origin, draw my triangle, and label A, B, C, and then set the shape in motion. So by noticing the coordinates, I have 1 unit here on the actual axis, 4 by 1 where the point C is, 4 by 3 where the point B is. Just noticing what ratios are used, because after the rotation, the same ratios will show in a different place. So let's say here, we're going clockwise. That means with the clock, 180 degrees. That means 2 quarter turns. So this arrow will have to go 90 and 180. The arrow should be pointing down after the rotation. So here we have 1/4 turn, which is 90 degrees, and then 180. Make sure that we line up that center of rotation with the grid, and here's now the reflection of A, which is A prime, so that will be our image after the rotation, and then C will come up here and it will follow the same exact ratio. So A will be 1 unit, then we have from there 1, 2, 3, 4 by 1, 1, 2, 3, 4 by 1. C prime. Transferring your labels will help you with identifying the new vertices as well. And then B from A is 1, 2, 3, 4 by 3, just like it was here, 4 by 3. 1, 2, 3, 4 by 3. And that's B prime. Connecting your vertices result to your image after the rotation of 180 degrees clockwise. Let's use the transparency to rotate quadrilateral ABCD 270 degrees counterclockwise, so we're going against the clock, about, meaning around, center of the rotation 0, 0, so the center of rotation is 0, 0. How far? 270 degrees. So now this quadrilateral has to be turned counterclockwise against the clock. So turn, turn, turn counterclockwise. On the transparency, we transfer our center of rotation. That's the starting point, the actual quadrilateral, the label of vertices clearly identified. The center of rotation is marked with 0. That means if I start here, quarter turn, 2, 3, to have 270 degrees, we need 3 turns against the clock. So this arrow should go 90 degrees, 180 to 70, again counterclockwise. So here we go, 1, 2, 3. Once you have your 3 turns done, make sure that if something moved, you line it back up to make sure it matches the grid, and here is your image. So if you're not sure, let's do it again. Counterclockwise, we go 3 turns. 1, 2, 3. Line up. The center of rotation is right in the center, and then transfer the vertices. And that is going to be our D. So that one is the D prime. And C prime, A, and B prime. 1, 2, 3, 4. The quadrilateral A prime, B prime, C prime, D prime after the counterclockwise rotation of 270 degrees. Every corresponding sides of the pre-image have to be congruent to every corresponding side of the image. So AD having the ratio of 3 by 3 is the same as A prime D prime, or BC having the ratio 2 by 1 is the same as B prime C prime. So another way to check is to make sure that every corresponding side is congruent from the pre-image to the image. So let's see how to rotate a triangle with the given vertices around the center of rotation -1 2. So negative 1, 2. Now here will be the center of rotation. Center of rotation can be anywhere on the coordinate plane. We're going clockwise, so with the clock, 90 degrees, 1/4 turn. So with the transparency, I can mark again my center of rotation right away. Center of rotation is where we set the object in motion from. The triangle and the vertices ABC clearly identified, as accurate as you can, so we can see how long the sides are. And then we're going clockwise, so we're going that way. We remember the motion with the clock, and it's 1/4 turn. That means this arrow should end up here, so 90 degrees turn. Center of rotation lined up, and the new vertices will transfer. So that would be A prime, then 4 units from A is B prime, and then 4 units straight down from A is C prime. And once we connect them, vertices A, B, and C, we have our triangle rotated clockwise, and the center of rotation was right here, point negative 2, 1. So the motion was clockwise, 1/4 turn around the center of rotation, negative 1, 2. The same exact center of rotation, negative 1, 2, but then same exact triangle, we're going to go against the clock, counterclockwise, 180 degrees. Let's see where we end up in that situation. Since I already had this triangle ABC, I'm going to just reuse it because I have the same center of rotation, negative 1, 2. I have the same triangle ABC. The only difference now is that I need to go counterclockwise 2/4 turns. So here I go. 1, 2. So line up the center of rotation, and then notice that the points will be transferred using same ratios. So here we have A prime, and then 4 points straight down will be point B, and then 4 points straight across, 4 units straight across will be point C. Connecting the vertices will result to the image A prime, B prime, C prime. Triangle ABC rotated counterclockwise 180 degrees. Let's see, one more example or two. Rotate 90 degrees counterclockwise about center of the rotation 2, 1. I'm gonna get you started. 2, 1 is right here. And then you have to identify the coordinates of the image B prime. So this B, after the counterclockwise rotation at 90 degrees, where would it be located? The center of the rotation is 2, 1, right here, that overlaps with point F. That's your center of the rotation. The shape itself. And then you're interested in this point B. So in the question, we have what would be the coordinates of point B. So I'm going to just label that point to see where would it be. Counterclockwise, that way. How many degrees? 90. So here we go, 1/4 turn. This arrow will be over here on the left side, 90 degrees. All right. So by transferring the shape, you have the whole shape, but you are interested in then that point B, which is from C, 1, 2, 3 points away. 1, 2, 3. B prime. Is your shape, image after the 90 degrees quarter turn. So here where it was, turn, and here's what it is. The question is, what is the location of image B? And that would be negative 2, 2. So the question is just about 1 point. Given 1, 2, 3, 4, 5, 6 points, we have to know how to rotate and then how to read the image. Here we have to rotate a trapezoid 270 degrees clockwise about the origin, and then what would be the coordinates of the obtuse angle of the image. So first what we want to do is use the origin as a rotation center, rotate the trapezoid 270 degrees clockwise, and then identify where would be the location of the obtuse angle. So we have right, acute, and obtuse. So this is going to be, after the rotation, your question: what are the coordinates of the obtuse angle after 270 degrees rotation clockwise around the origin? I'll let you try that and we'll see what the answer is in class.